Welcome to all. Class number 42 of our course SFD BMD. See, class number 41, I considered simply support beams, u.d.l over entire span. Today also same. Do not think that it is a repetition, not that way. There, I put, if I remember, I correct, Roman 4. Once again I will tell you. Roman 1 stands for central point load. Roman 2 stands for two symmetrical point loads. Roman 3 for eccentric point load. Roman 4 for u.d.l for entire span. There I put A and B. A means bookwork type questions. B means numericals. Last time bookwork over. So today it is B. 1 minute. I already told this course will be a systematic course. Complete coverage. I will see that those who already know the subject, maybe they will feel this such again and again bookwork over, numerical we can do. Yes, they can do. But there are so many people, those who are learning, they have difficulty to differentiate between bookwork question, that is w.l given, or numerical given. Those who are not interested or those who can solve numerical, they can solve themselves only. But still, there is a proper way of solving. So many people, they will solve. But the proper way solving will not be there. What happens is, if you don't solve proper way, control will not be there. But anyway, I told my course is for complete coverage. Okay, start. B. Question is, I will write here. A. Simply supported beam of span, any span, say 10 meter, some span required, 10 meter, is loaded by an uniformly distributed load, or short form u.d.l of intensity. Very important. See, I will tell you afterwards why important. The word intensity is important. See a little later why it is important. Intensity, say for example anything, 30 kilonewton per meter over entire span. Okay. Now draw SFD and BMD for the beam. Remember now, we will draw SFD and BMD for the beam in the same way as last time when I considered u.d.l as W per unit length and span L bookwork. So you should know. But one more thing, you should not see that question and substitute W equal to 30 and L equal 10. That is wrong. You solve independently, systematically. In the end, I will tell you easy method. Therefore, remember, easy method will be clear when everything is perfectly known. So, I will start solution here. See, briefly, solution. I will write the beam here. See, systematic means full systematic. Beam span is 10 meter. A and B. They told u.d.l of, not they told, I only told, u.d.l of 30 kilonewton per meter over the entire length. Required to draw SFD and BMD. Just checking. Okay. I want to write that 30 should come little down because partially not visible. So I will write here 30 kilonewton per. I should always consider this fact that should not go out of camera. Kilonewton per meter. This is B. We have to draw SFD and BMD. See, systematically solve. First step, calculation of reactions. I won't waste time telling vertical reactions, all etc. Those who want can write here. See, statement I am giving. Both are simple supports, or it is as good as one hinge, one roller. If hinge support is there, horizontal reaction is possible. But for SFD BMD, you need only vertical reaction. So, someone can comment, if I apply horizontal load, this beam is unstable. I will tell I am not applying horizontal load. Have you applied horizontal load? No. Then keep quiet. Sometimes harsh answer required for people who unnecessarily comment. Okay. Now, you can write let VA and VB be vertical reactions. I am solving as if what? The previous question is not solved. Let VA and VB be vertical reactions at A and B respectively. You have to write, those who are serious. Then one more sketch I will write. See, this is what is called systematic. Once you understand, then there is no problem. See, one more thing I will inform now. In this series of SFD BMD, parallelly in between, see, you know, during this course, I am giving mathematical concept class. That is separate heading. And also in the same series SFD BMD, in between I am going to put objective type questions. Very useful for those who are writing competitive examination. I will tell all the tricks there. In the objective questions, I will tell lot of tricks. Sometimes for a beam, if you struggle, it may take 10 minutes for you to get the bending moment maximum. I will tell the trick, you will get it in 2-3 minutes. And objective question, which systematically if you solve, you may take 2-3 minutes. Here, you will take only 20-30 seconds. I will tell that one when the time comes. So then I will upload one thing. I will write course SFD BMD. Class will be continued. And before that I will write objective type questions for competitive examinations. Then I will put further. This statement will not be there. It will be new series. I will tell objective type questions. Then part 1, part 2, part 3, part 4 will continue. But next class may be some other number. Continuation here. Okay, start. A and B. How much it is? 30 kilonewton per meter. When you learn, always you see that learning is systematic. See, start. I told you last time, to find reactions, you can apply or you have to apply sigma m0, sigma v0. This is equilibrium conditions, direction based. That's all past. Now, no. Now onwards, which concept I thoroughly told earlier, which one? Reaction calculation, equilibrium is direction based, SFBM is nature based, their direction is not to be considered. Such things I am not repeating now. People who study systematically, they will understand and gain tremendous knowledge. People not interested, not seeing all the previous classes or going through all the classes, suddenly coming and going through a part of it. For me, whether they see or go through the class or not go through the class hardly matters. As I told, my class meant for people with seriousness and dedication. So start. But not required because symmetry is there. So I will write, see, I will start now. DTS. In my class, if now onwards, if I write DTS, you should know what is DTS. So whenever I write DTS, it means due to symmetry. Don't ask me next time. Anyway, you can't ask also. In the comment box, do not write what is DTS. I will put a harsh comment then, not very harsh. If you want to know what is DTS, go to earlier class and see why suddenly came to this class. So, due to symmetry, directly you can tell reaction VA equal to reaction VB at B, sorry, not V, reaction at A equal to reaction at B equal to total load on beam. Total load on beam is total vertical load, understood. Vertical load on beam in the downward direction. Whatever downward direction total load is there, divide by 2 will give each vertical reaction in the upward direction equal to 30 kilonewton per meter for 10. Very sorry, I can't explain further. Divide by 2. This has been told more than 1000 times earlier. 30 into 10 is 300. Each will become 150 kilonewton. Okay, now you know correctly reactions. Now start SFD BMD systematically as if this is a bookwork question. I will rub everything now. Start fresh now. I change the board, so rubbing I can do easily now. See. Fresh page, write the beam here. Little down, because space problem. Okay. Put the beam here. This is A and this is B. u.d.l is 30 kilonewton per meter. You never see previous question, never see that WL etc. Do it as an independent question. This is 10 meter. And then we know that reaction VA equal to 150 kilonewton, reaction VB also equal to 150 kilonewton. Okay. Now, this first, what you have to know? Now, I told first to solve it systematically. So, I am also going systematically. See, first, what you will do is consider section. I will use a red color to understand XX. Oh, it is not red color. Okay, no problem. That thing happens. Section XX between, short form, see, if I write B by W means between, some time saving required, between A and B, that will be black color only, between A and B, comma, at a distance X from A. That means your A is origin for X. See, your X will go this way. So, take a section here, anywhere you like, XX, anywhere you can write, I will mark X here. See, I will mark X here. Now, start directly. Now you can do one thing, SFBM, both you can do simultaneously also. See, first write, shearing force at XX, that is called Vx equal to left up dot dot right down positive. I told this one. So, look this side. It is plus 150 minus load from here to here is 30 multiplied by X is the shear force. So, see, highest power of X is 1. That is, you can tell linear variation. Linear variation. Okay, leave it. And also, you can make 2 in 1. And also, now only bending moment at XX. That is called Mx. I can make better this also red color. Mx. Now remember, bending moment. We will take sagging positive equal to, look this side. If I look this side here, plus 150 into X, plus 150 into X minus 30 into X is the total load from here to here into center. Already told so many times earlier, X by 2, or if you simplify, you will get, or if you write once again if you want, Mx will be equal to 150x minus 30x square by 2 will be 15x square. Okay, I'll round off this one. I'll round off this also. These are the expression for SF and BM with sign convention. I wrote here sagging positive. Okay, now highest power of X is 2. Therefore, you can tell parabolic variation. Parabolic variation, and in the bracket second degree. I also told this one, second degree. Now start. First, to draw SFD. To draw SFD. What you require? You know expression for shear force at any section between A and B, and remember this X will vary from 0 to 10. You can make a small note here if you want. See, X varies from, that is not required. I write here 0 to 10. Those who want can write here. This is how X varies. Variation of X. Variation of X. And next time I won't write these things. Understood? Okay, 0 to 10. Start. Now, to draw SFD, substitute X equal to 0. That is, section will come here now. That is, you will get, therefore, you get shear force at A. I won't call VA because VA is the reaction. Shear force at A. When you put X equal to 0, direct answer write 150 kilonewton over. Then substitute X equal to 10 meter. Therefore, you get shear force at B equal to here plus 150 minus 30 into 10 equal to minus 150 kilonewton. Therefore, immediately one diagram, see, one diagram, I'll use it there. That space is not required. I'll maintain that heading because it should be visible up to end of the class if possible. So that anywhere you see, you should know what you are doing. If possible only. When space problem comes, I remove everything. Therefore, see, I will draw a diagram here now for the beam. This is A. Finally, you are drawing combined diagram. Lastly, AB. Then shear force at A is plus 150. Write upper side 150. Do not write plus 150. Here, minus 150. See, I told so many people, they write minus 150 here. Then variation is linear variation joined by a straight line. Then they will write plus here and minus here. See, no, this is not correct. If you are putting plus and minus here, do not write minus 150. Write only 150. That I already told. Simple thing, but important. Okay, this is the shearing force diagram. Now, shearing force diagram will cross the baseline. So, this point you have to locate, but not required because directly you can tell, no need of wasting time. Sometime it happens. See, this is 150. This is 150. You know how to locate this point in my mathematical trick class, that is a concept, class number 1. I told, suppose this is 20, this is 30. How to locate this point directly I told there. But here not required because when these two are equal, this should be midpoint. So common sense, you can write here, SFD will cross baseline at center. Center, say some name. I will call the point as C. Say C. That is at what distance? When this is 10 meter, at 10 by 2 equal to 5 meter from either A or B, anywhere. You can tell either from A or B, it is 5 meter. I will come back here and enter the answer here. This is 5 meter. Remember, calculated value. This also 5 meter, calculated value. Over. Okay, now SFD is over. Now come to BMD. Or I will do one thing now. I will remove the SFD part and SFD already I drawn. I will go to BMD now. See, when you want BMD, see, I can remove the SF equation now. It is already over, SF equation. I will remove the SF calculation all. This will be there. I will remove all this, not required. Even SFD also I will remove now. Why? Already over. Okay, start. We know now to draw BMD. You continue from there. You should make systematic notes. And I will tell you one more thing now, right now. I am planning to make a systematic notes with no corrections and if possible minimum corrections. Means what? I will try to avoid corrections and no calculation point of view minimum mistakes and complete subject to be covered. It will come around maybe 300 or 400 pages. Oh, but I read time. I got lot of commitments now. I find difficulty even to upload this class also now. And one more thing I will tell you now itself. From past 5 days, there was a problem of weather problem here. Daily when I am ready for recording after 9 o'clock in the night, heavy rain comes here. And during rain, sound will come, so recording will not be clear. So finally today, weather is kind on me, so I am recording this class now. Hope it will not come for at least some half an hour more. Okay, start. To draw BMD. We already know expression for BM. See, mx equal to 150x minus 15x square, parabolic variation, second degree. Now, what you have to do is equation, substitute. So, if those one can write, we already obtained the expression for bending moment, mx equal to 150x minus 15x square, x is from A, you can write it. To make more clear, start. Substitute x equal to 0. You get therefore When you put x equal to 0, you get bending moment at A. Answer. Directly you can tell 0, 0 is there, 0. Don't show the calculation. Somebody will laugh. When both place x is there and you substitute for x means what is this one? Okay, then substitute x equal to 10 meter. You get, therefore, you get this comma is not required. Bending moment at B. Actually, you know the answer. Here also 0, but you have to get it now. It is plus 150 into 10 minus 15 into 10 square. You calculate, I will not calculate, it is 0. Okay, now draw the diagram. No. Then what will happen? Someone will tell BMD, here 0, diagram over. No. It is a parabolic variation. See, we already got parabolic variation. Or, if you remember, there is a principle. Whenever there is a parabolic variation is there, BMD is incomplete unless you decide where BM is maximum or minimum. It is compulsory. So therefore, continue now to get maximum BM. See, I know that it is, see, usually to save time, I will not write a maximum MAXIMUM. I will put always this way, maximum BM. See, time also counts. Okay. Maximum BM. See, first of all, we have two options. See, option 1. Option 1. We know, you can write, we know that BM is maximum or rare cases minimum also, but today maximum, where SF equal to 0 or where, one more thing, sometime SF equal to 0 or sometime in case of point load solve or where SFD what? Crosses baseline. Crosses baseline means baseline. Or you can tell changes sign. Both are same. Changes sign. Both are same. Okay. Both are same. Now, here, already SFD over here. Refer SFD. Refer SFD. Already drawn. I removed it. But by this time, you should have drawn it. If you are serious, by this time, what I removed earlier, it should be there in the systematic way. Refer SFD. You can tell shear force is 0 at center. That is C. Therefore, that is x equal to, if it is center, x equal to 10 by 2 meter or 5 meter. Or actually, we already marked 5 meter. 5 meter from A or B, but here x is from A, 5 meter from A. So, now, substituting x equal to 5 meter, you find BM, okay, right, directly, BM equal to, where is the equation? Here, 150 into 5 minus 15 into 5 square. What the answer now? 150 into 5 minus 15 into 5 square. Calculate into 5 minus 15 into 5 square. 375 kilonewton meter plus 375 kilonewton meter. So you can tell, therefore, maximum BM will be equal to 375 kilo plus kilonewton meter, where directly you can tell at center. Over. This is option 1. I written option 1 here. I think I not written. Option 1, I forgot. Option 1. Okay. Now, second option. See, I remove this one now. So, option 1, we got 0 at left end, 0 at right end. See, when I point my finger here, I told 0 at left end. For me, it is right end. But I am looking at, I am imagining your position. So, I will tell left hand. Tell right hand. Sometime in the class I will tell. Ask, just for fun only. Left or right. Student will tell, sir, for us it is left, sir, but for you it is right. I will tell them, you never bother what is for me. You tell what is for you, sir, left, that's all. Do not worry about me. You are learning, I am teaching. Therefore, you tell for you what? Sir, left side, sir. That's all. So, left hand 0, right hand 0, and center is maximum. And you know, it is a parabolic variation. And I already told you earlier, parabola will be like this. Reason I will tell. So, before option 2, I can tell. Therefore, as per option 1, the BMD will be 0 here, 0 here, maximum at center 375, and it will be parabolic variation. I will draw as smooth as possible, and you put a tangent 0 here. See, why parabola this way? I told. Once again observe, SFD is like this. See, maximum shear force. So BM, the slope should be maximum here. Maximum negative shear force here. See, the slope again is maximum in opposite direction. Shear force is 0 here. Slope is 0 here. Or as you go from here to here, shear force reduces. So the slope should keep on reducing. Finally, when you reach center, slope should be 0. Then again slope will start in other direction. This already I told you last time. So I need not tell. Concept once told need not be repeated. Next time I will tell, refer earlier told. I told everything you should go through if you want thorough knowledge. Okay, over. This is plus sign. This is a BMD as per option 1. Now I will go to option 2. See, option 2. This also I did last time. Option 2 is not referring that maximum BM. See, purpose is to get maximum BM. How to get maximum BM is option 2. Option 2, we will not consider or we will not check where SFD crosses baseline and or where SF is 0 and find BM there. We will use mathematics. We know equation for BM here. See, we have mx means what? Bending moment at any section between A and B equal to 150 into x minus 15 into x square. Red color I am not writing. Okay, write red color. X square. Already told parabolic variation. This is a parabolic variation bending moment. No. We want maximum value. When you put x equal to 0, you got 0. When you put x equal to span 10, again you got 0. In between, there is a maximum. So, now, for mx to be maximum, mathematically, differentiation of mx with respect to variable x, dx, okay, dx should be equal to 0. Now, differentiate, next time I will put diff like that. Differentiate mx with respect to x and equate to 0. Equate to 0. What you get? Therefore, you get dmx by dx equal to 150 minus 15 into 2x equal to 0, or you can tell somewhere here 150 equal to 15 into 2 is 30 into x, x will come 5 meter. Therefore, bending moment is maximum at 5 meter from A. Why A? X is from A. Now, substituting x equal to 5 meter in mx expression, that is expression for bending moment. In mx expression, you get mmax equal to, where is the calculation? Yes, equation here. 150 into 5 minus 15 into 5 square, it will come same as last time. How much you got? Already, I don't have to calculate once again. I think 375 came, I think. Okay, let me check it. It's still showing. Yes, 375 kilonewton meter plus 375 kilonewton meter. Therefore, I will write here now. Here only I will write. Therefore, the space problem here. Bending moment diagram will be 0 here, 0 here, little down. 0 here, 0 here, maximum here of 375, parabolic variation is gone. Slip of the hand means gone. Okay, parabolic variation, this is 375 here plus, this is the bending moment diagram for the beam, sagging positive. So we got bending moment diagram. Now we will sketch the beam once again systematically and draw SFD BMD using the result we got just now. Then I will tell you how easily you can draw. 1 minute. So I will remove everything now. Full I am removing. Nothing required now. Only diagram. See. Always remember, systematic study will give tremendous knowledge. You see later, systematic study will give unparalleled knowledge. Start fresh page. We will write the beam here. As neat as possible. See, when curvature comes sometime, I should be careful. I should actually tell one more thing later for you. See, when I go for partial u.d.l all, I will tell you what is the common mistake made. I will correct that one. u.d.l of 30 kilonewton per meter. You can write this reaction VA equal to 150 kilonewton, reaction VB also equal to 150 kilonewton. Draw the baseline. This is your shearing force diagram. All values are kilonewton. See, last time book work, I told no kilonewton, no meter. So many places they tell a load of W kilonewton per meter. No, it is wrong to tell unit for bookwork question, bookwork type problems. You should not use unit. It is valid for any unit. Kilonewton. And also sign required left up, right down, positive. See, up to some limit every class I will write. After some time, when you finish around another 10-15 questions, then I will tell. Now onwards, I cannot waste time every class this formality. I will tell formality, formality. Okay, start. Or I will do one thing. The baseline I will make slightly color. Okay. Go up by this is 150. Here also 150 got negative. Don't write minus 150. Center is crossing baseline. This is the shearing force diagram, plus and minus. You can tell sometime A, B, C all not required. Okay, I'll write here. A, B, this is C. C, we already know it is center. I forgot to write their span. Okay, 10 meter. Okay. Then you should tell this distance here is 5 meter. Even this also is 5 meter. Then below, draw bending moment diagram. See, I will tell one more important point for you. It will come in objective question later. Bending moment diagram, all values are in kilonewton meter. Sagging positive is a sign. I will tell it later how to draw BMD on tension side. You ask anything, I have solution. Remember that one. I will tell later. You can even in the comment section ask what questions you want. I will solve. Provided it is provided not that I know about it. Provided in the course it should be admissible. For one or few people's requirement, I cannot go beyond the course, beyond the limitation of the course. So I will see the question. Any type of loading, you can tell couple here, couple there, between you want couple, between u.d.l, end of u.d.l. You can comment. I will put one by one classes. Or I will tell this is already over, refer so and so class number. And if comments are more and more, I will not be able to reply for each and everything. In the class I will reply. I will go through the comment. In the class I will tell next class, I got this comment, so clarification for that one. So this is a BMD, sagging positive. See, 0 here, 0 here. center is maximum 375. Should not write kn meter because already you wrote here. Now, join by parabola. Reason told. See. Smoothly drawn. Remember now, if you find the ordinate here at a quarter span, that BM will be 3/4 of this value. This I will tell you in objective type questions later. Not now. Objective question I will tell you. Question will be, how maximum BM is how much percent more than the BM at a quarter span. Then next objective question. A beam is loaded by a u.d.l. Now, if the u.d.l is replaced by a point load, find how much BM will change, increase or decrease. I know it is increasing. They may ask you only change. Then you should decide increase or decrease. But they may ask you how much BM increases. Or a central point load applied. Instead of centrally applying it, if you shift it to some other point, see how much BM reduces or what is the percentage reduction in BM. All those. Then sometime SFD will be given. Using SFD, you have to find BM. Or sometime SFD given. Using SFD, you have to get the what? You have to get the load. Or BMD given. Using BMD, you have to get SF. That all will come for objective type question. I told actually some of them will come here also. That I will upload in between under the heading class number 42. That will become same. It will become not 42. That suppose 43, 44. No, I will put new number. Class number 1. Objective questions. Part 1. That way I will continue. Or part 1 not required. Why? Class 1 means part 1 only. That is to help people who are preparing for competitive examination. In case I told if I get very good response, then deflection chapter I would like to come live. But I already told to come live, I need sufficient audience, not just some 50, 100 audience like that. I feel I deserve much more. When I feel that lot of people will come live, then I will start deflection chapter. See how powerful, how easily and how systematically and also tricks will be told and easy solution will be given. Lot of tricks are there with me. I will give one by one when the time comes. Okay, start now. This is plus. See, again, some will tell, sir, slight curvature. Do not comment on unnecessary these things all. Plus. Over. This is the bending moment diagram. Over. Now, just to understand, I told you, you can draw BMD very easily also. See, I will not see there now. See, this is how to draw SFD and BMD in shortcut. See correctly what I am doing now. Mark the beam. u.d.l of how much? 30 kilonewton per meter. Span is 10 meter. See. Directly A and B, nothing else. 30 into 10, total load 300 down. Each reaction directly 150 kN, 150 kN. You need not write VA also. Why? This is shortcut. You know it is VA. Then go to SFD. Start. No equation. Go up by 150. I told you. From here to here, gradually come down by 30 into 10. 30 total load is 300. So you are upper side by 150. From here, when you come down by 300, you will reach here. This will also be 150. It will cross the baseline here. So it will come like this, 150. Now, since both are equal, this distance is exact center, 5 meter, and this also 5 meter. So you can tell this is C, which is center. Then draw BMD directly. Bending moment at B, look this side, 0. Bending moment at A, look this side, 0. Bending moment at center, where SF is crossing baseline, look this side. You should mentally calculate or take your calculator if you want to write. See, BM at C equal to, look this side, plus 150 into 5, I'm not calculating, into 5, minus 30 into 5 into half of 5 equal to plus 375 kilonewton meter. Enter here. 375. And u.d.l is there, parabola. Whether parabola is like this or a parabola like this, you can make out here. Here maximum shear force, slope should be maximum. Here zero shear force, slope should be zero. So curve will be like this, somewhat as smoothly as possible. I have drawn. This is SFD. Other things you write yourself only. What? Like, okay, I write this time. SFD all in kilonewton. Left up, right down positive. BMD all values in kilonewton meter. Sagging positive. Okay. This is shortcut way of writing. Now, I will give you one more shortcut. Okay, where I should write here? Here I will write one more shortcut. Simply support beam, see, u.d.l of 30 kilonewton per meter. Span 10 meter. Remember the bookwork. Everybody knows. Shear force diagram comes this way in the bookwork. WL by 2, WL by 2. BMD comes this way. Parabola WL square by 8. So equal to W 10 into 30 into 10 divided by 2 equal to 150 equal to 150. WL square by 8 equal to 30 into 10 square divided by 8 equal to 375. Further shortcut. Now you can make a note. I will give in the notes that one. Result I will give. Standard or in the class only I may give. After all the standard case over, one class I will give a list of the standard cases. Central point load, eccentric point load, two symmetrical loads, u.d.l full span, u.d.l half span, u.v.l like this, or u.v.l like this, or u.v.l like this. Then for cantilever saw or overhanging beam, u.d.l with the ratio, different ratio of overhang to span. Some principles are there. How to get that ratio of overhang to span to get maximum BM as less as possible, or further, when for what ratio beam between support will sag, for what ratio it will hog, and for a particular ratio BM will be 0. That all objective questions required, but I will do systematically, theoretically, and also explain in objective questions. So, okay, now I think everything will be clear now. Here, see, I think forgotten. Somebody will comment. He wrote everywhere sign, one place sign not written. Take it. Minus. Okay. This is SFD BMD for this class. Now, I will tell you, this is Roman 4B. Now, next class, I will give a small class I will upload in between. Very simple class. Sometimes, instead of giving intensity, they give total load. Or, in the bookwork, they will tell loaded by total u.d.l, total load due to u.d.l how much. So, instead of giving W per unit length, they can give total load is so and so. Not difficult, very simple. That I will take next class and tell goodbye to simply support beam with full u.d.l. But one thing pending, the area of this BM diagram and locating CG for full and half, full area and half area, and CG for full BMD and half the BMD, that I told I am deriving. I thought first doing that only now. No, I decided, let me go to cantilever, or little later you get more and more practice. Then suddenly I will tell you, today we will go for how to get area, 2/3 base into height, that 5/8, 3/8 for simply support beam, for cantilever 3/4, 1/4, and so many places, majority or maximum places I have seen people making mistakes where it should not be used, they use the formula. Those formula has limitations. That all we will discuss in the class little later, or when I feel you are ready for it. Now it is too early, because why? You have just started the diagram. So we will go at least 2-3 classes systematically, understand everything. Then when the time comes for a little more understanding, then I will go for that one. Okay. Thank you.